Good afternoon, everybody. My name is Vidoe. I'm a telecommunications student at Politecnico di Milano. In this presentation, I will be discussing a familiar topic on mobile radio networks. This is an overview on massive MIMO systems for 5G and beyond networks. In this presentation, we will discuss the key enabling technology required for 5G and 6G networks. Also, we will discuss all the fundamental challenges, including pilot contamination, channel estimation, um, pre-coding, and so on. And finally, we will outline recent trends such as terahertz communication, ultramassive MIMO, visible light communication, and so on. Here we discuss key enabling technology. The capacity of massive MIMO system to increase throughput and spectral efficiency has made it a critical technology for emerging wireless standards. The key here is the considerable area gain that massive MIMO system achieves with a large number of antennas. Um, as you know, the data collection from the large number of smart sensors using traditional multi-access schemes is very impractical and difficult as it leads to excessive latency, low data rate, and reduced reliability. Therefore, the growth in mobile data traffic and the number of connected devices to network made it necessary to use uh, massive MIMO technology to help 4G and 5G networks. Uh, in this picture, the evolution of mm, first generation to sixth generation of networks, mobile radio networks, um, is shown. As you know, 5G provides us with a wide range of advantages, including spectral efficiency, energy efficiency, high data rate, user tracking, low power consumption, less fading, and so on. But we always have challenges with every new technology. These challenges and difficulties for 5G are including frequency bands, coverage, cost, security, and privacy, availability, and so on and so forth. Here we provide three of key enabling technologies, including full duplex technology, beamforming, and the last and the most important one is massive MIMO systems. In this table, the comparison between traditional MIMO and massive MIMO systems are presented. In traditional MIMO, the number of antennas was less or equal to 8 in 8, but in mass MIMO systems, it increased to it is at least 16 in 16 area of antennas. Um, using more antenna will help the more small antennas in array form will help the system to have the pencil beam, which will help for in 5G and 6G networks. The other advantages of massive MIMO compared to traditional MIMO is it has high throughput, it has a high level of scalability, high level of link stability, um, and so on and so forth. And you can see the other advantages in the table if you wish. Here we present fundamental challenges. The fundamental challenges are including pilot contamination, signal detection, channel estimation, pre-coding, hardware implement, user scheduling, and so on and so forth. Here we discuss pilot contamination. As we know, if the pilot signals in the home cell and neighboring cells are orthogonal, the base station um, obtains the review, obtain the um, you know accurate estimation of the channel. However, the number of orthogonal pilot signals in given bandwidth and period is limited, which forces the reuse of the orthogonal pilot in neighboring cells. The same set of orthogonal pilots used in neighboring cells with interfere with each other, and the base station will receive a linear combination of channel response from the home cell and the neighboring cells. The phenomena is uh, known as pilot contamination, and it limits achievable throughput. The other challenges is channel estimation. For signal detection and decoding, massive MIMO relies on uh, channel channel state information (CSI). If the CSI is perfect, the performance of massive MIMO system grows linearly with the number of transmitting and receiving antennas. For a system using frequency division duplexing (FDD), CSI need to be estimated both during downlink and uplink. During uplink, um, channel estimation is done by the base station with the help of orthogonal pilot signals sent by the user terminal. And during the downlink, the base station sends pilot signals towards the user, and the user acknowledges with the estimated channel information for the downlink transmission. For a massive MIMO system with many antennas, the downlink channel estimation strategy in FDD becomes very complex and sophisticated and infeasible to implement in real world applications. And finally, in this section, we will provide some recent trends to you. The first one is ultramassive MIMO, terahertz communication, visible light communication, machine learning, and deep learning for massive MIMO system. The fourth trend is very important for us. As we know, machine learning is a subset of artificial intelligence, which is known as a powerful tool for classification and prediction problems. Deep learning is a subset of machine learning, and it uses more advanced tools capable of building universal classifiers and approximate general functions. Both machine learning and deep learning are very critical technologies for the design of 5G and 6G networks. Massive MIMO requires a very complex optimization, and the traditional algorithm such as stochastic geometry and game theory are very sophisticated and complex and requires enormous computation power. The dynamic nature of machine learning and deep learning algorithms could be instrumental for their complex analysis. It could save a considerable um, amount of computational power. Here we have some questions. Can our current mobile phones use massive MIMO technology? Our current phones mm, do not support massive MIMO systems. And you can't buy a massive MIMO ready phone yet. Even if you buy a phone which supports massive MIMO, it will not be beneficial until we have massive MIMO supporting wireless networks. Mm, um, I appreciate your time and consideration. In case of having any question regarding this presentation, please feel free to contact by my mail. My mail is hamed.lotfalizade@mail.polimi.ir. Goodbye.